Okay, so guys, I'll start after 5 minutes. Okay, so let's wait for 5 minutes and after that we will continue. Okay, so guys, I hope I'm audible to everyone. Just type yes in the chat if I'm audible. My screen is visible to everyone. Okay, let's hold on for 1 minute and after that I'll just continue. Hello everyone, my name is Hemu and today's we are here to discuss SSL Handshake, how it works, all these type of things I'm going to cover in this particular lecture. Okay, so before starting this particular SSL Handshake, the actual topic for this particular session, let me just give you one announcement. So guys, as you know, we are starting one PaloAlto plus F5 LTM combo live batch from 24th of Feb, and the timing for that batch is 9 a.m. to 11:30 a.m. IST. Okay, so if somebody interested for this particular training, you can basically enroll the training, and right now we are just taking the enrollment for that particular training. And whatever the topic I'm covering today, it is also part of your Palo Alto training, right? And nowadays, you know, in this particular topic called SSL handshake is asked by in almost all type of interviews, right? So that is the main reason I'm just covering this particular topic, right? So one more time, guys, just confirm if I'm audible, any lag on my voice, everything is good. Are we good to start, guys? Okay. Okay. So let me tell you guys, so this particular training, Palo Alto plus F5 LTM, fees for this training is 12,000 INR. First, we will basically cover your Palo Alto. Once Palo Alto will complete, we will start your F5 LTM. And timing, as I mentioned, 9 a.m. to 12:30 a.m. IST for Palo Alto and 9 a.m. to 11:30 a.m. IST for F5. So guys, for Palo Alto, it's 9 a.m. to 12:30 p.m. So like in Palo Alto, it's around 3 hours of session, and generally F5 sessions will be of 2 hours, right? And first we will cover your Palo Alto. Once Palo Alto will complete, we will start this F5 LTM. Now, Let me just tell you what are the things I'm going to cover. So guys, your Palo Alto Firewall training will go around 40 plus hours of training, which means we have around total of 16 classes, and each class will be of 3 hours minimum. So it will go around 40 plus hours of training, somewhere around like 48 hours. Once this particular Palo Alto will complete, we will start your F5 LTM, and F5 training is around 32 plus hours. In F5 we have around 12 total of 12 classes. Okay. Once your Palo Alto will complete, we will basically start your F5 LTM. And as I mentioned, fees for this training is 12,000. In this training, you will get the lifetime interview support. You will get the documents which you needed to basically, if you are planning to write any type of exams, or let's say you are preparing for the interview, right? So these documents will help you in these cases. You will get the access of recorded session with the lifetime lab setup. We will help you building the lab in your laptop. If your laptop is not having sufficient resources, then we will help you building the similar type of lab on the Google Cloud. It's a weekends based. So guys, these classes will happen on Saturday and Sunday only, because me and Vidit sir both are the working professionals. So we used to only have time on the weekends. Okay. So just mention it's a weekends classes. You can also able to discuss any type of practical issues or live issues if you are facing in the production environment during the training. We will also help you, or we used to provide the mock interview support with every student. Let's suppose you have an interview, right? And if your interview, let's say you have an interview, in that case, what you have to inform us around 3 days before. What we will do, we will take your interview and we will tell you these are the areas where you have to basically work, or these are the things which you have to prepare. So that's how you will get to know what are the things where you are lagging and all. Okay. Guys, Palo Alto course content I will cover after our topic, which is SSL Handshake. Now, let me just first go through with the SSL Handshake, how it works, right? And everything. But before that, if you will go here, see, we have a website like learn.sianets.com, where you can able to find all the courses which is offered by us, right? And here you can able to find lots of courses on Palo Alto, F5, LTM, GTM, ASM, Palo Alto Panorama, Palo Alto IPsec VPN, AWS network, AWS security, right? We have a Python for network automation, Wireshark, Checkpoint, Fortinet, all such type of trainings are there. Okay. This is my YouTube channel, right? So in this YouTube channel, you can able to find lots of videos with regards to Palo Alto, Checkpoint, Cisco ASA, IPsec VPN, AWS, Cisco Biptela SD-WAN, right? We have a one more YouTube channel with the name Skilled Inspirational Academy, and here you can able to find lots of good material with regards to F5 LTM, GTM, ASM, FortiGate firewall, all these. Okay. So these are a couple of our details. And guys, who is interested for this training, what you can do, I'll share our numbers at the end. So on these numbers you have to contact. Now let me start with this SSL handshake. So guys, tell me one thing. Tell me one thing. I'll just go through with this diagram in some time. Let me just draw here my diagram first. So let's suppose I have a PC here. Let's take this example. This is PC01. Then this PC, let's suppose, have a connectivity with one of the firewall. For example, now this firewall will have a connectivity with the internet service provider. So this is your internet service provider here. And after that internet service provider, let's suppose we have one server here. So this is a server we are having, and let's suppose it's a web server running the web service on TCP port 443. Okay. Now It's SSL handshake, guys. Okay, not SHS. Sorry for typo. Now, guys, see on this particular web servers, I'm running the web services, right? Now, let's suppose now this PC wants to initiate couple of packets toward this particular server. Let's take an example. This PC have IP address which is 10.1.1.10, and let's say this server have a public IP address which is 33.33.33.33. It is having this particular public IP address. Right. Now, guys, let's suppose on this particular PC browser, we have just opened a website. We have typed HTTPS, then www dot, or not www, let me just go in this way. HTTPS, then 33, I have just directly typed the IP address. Now guys, tell me one thing. What is the first packet this particular PC initiate towards the server? What is the first packet this PC will initiate towards the server? So I have not seen like Gaurav DNS lookup will not happen because I have just typed the IP address directly. So I got the correct answer from couple of person. Like what it will do, it will send the TCP SYN request, right? So let's suppose somehow my Epic pen is very slow. Guys, whatever I'm typing here, it is coming properly on time or it is just lagging. So what will happen? It will send one request of one packet which is TCP SYN packet. Okay. Now let me just change the color here. Just give me guys 1 second, please. Okay. Somehow. Just give me 1 second. Let me just increase the size little bit. It is coming very small here. Delete everything. Yep, now it is fine. Okay. Yeah, it's fine now. So we have a PC here, PC1. And now this PC have a connectivity with one of the firewalls. So let's suppose we have a firewall here. And this firewall have a further connectivity with the internet service provider. So we have a ISP here. And this ISP will have a connectivity with one of the web server here. Let's say this web server hosting the service on TCP port 443. Okay. Now this PC1 have IP address 10.1.1.10 and this server have IP address 33.33.33.33. Okay. Now what I will do, let's suppose this PC will initiate couple of traffic towards this particular server. Okay. So now let me just put in this way. So these are the two lines I will use to basically draw the entire communication. Okay, cool. Now, as I was discussing, guys, see this PC will initiate a very first packet toward this server, right? Now, As I have mentioned, the very first packet which is initiated by this PC is a TCP SYN request, right? So when there is a SSL handshake start, what will happen? It will basically go through with the TCP three-way handshake. Means first TCP three-way handshake will complete, and after that your SSL handshake will start, right? So what it will do, the very first packet which is a TCP SYN request initiated by this PC towards this particular server, right? Now, when this server receive this TCP SYN request, so what he will do, he will respond, and he will respond with the second packet, and that second packet is TCP SYN plus ECK, and after that he will send the third packet, which is TCP acknowledgement. These are the three packets basically they will exchange at a first place. Once this TCP connects, these TCP three-way handshake will complete. What will happen? There is a one TCP connection is in a established state now, right? Means one TCP session will established, and the TCP stage right now it is in established stage, right? Once this particular TCP three-way handshake will complete, now guys, what used to happen generally, now they will start with the SSL handshake, right? In SSL handshake, the very first packet is always initiated by the client machine towards the server, and that the very first message is known as a client hello. Okay, the very first message in your SSL handshake is client hello. What are the parameters they will exchange in this client hello? I'm going to cover in some time. Okay, let's just first try to understand what are the packets they will exchange, right? And after that we will do deep dive into these particular packets, right? Now, let me just change the color here. Let me use this color, or let me just use this one. Now, see, now this client hello reach till the server. Now, what server will do? Server respond. And guys, when server used to respond, he will respond with second message, which is known as server hello. Server hello, server certificate chain, server certificate chain, and this server hello done. So guys, now these three messages, this server will send in a single message. Okay. In single message, you will get server hello, server certificate chain, and the server hello done. Okay. Now guys, see, once this particular server hello, all these things exchange, now what it will do, now this client, he will basically send one more message. So now what this client will do, it will send one more message. Anyone have any idea about what is the message content here, or what is the message this client will send towards the server this time? That message is known as a client key exchange. Client key exchange plus it will also send one more request, which is chain cipher spec, and client done. Okay. Now, let me increase the size a little bit more. Okay. Now what will happen now? This server will also reply. Now when the server will reply, what it will do? Server will send change cipher spec and server done. Okay. Now guys, let's try to understand each and every message in depth. How this particular exchange is happening and everything, right? So generally what used to happen, see, why we are learning here SSL handshake, because see guys, whenever you will use to configure your SSL VPN, or I can say remote access VPN, right? Like your like your Global Protect in Palo Alto, or like Cisco AnyConnect, right? Or whatever website nowadays using HTTPS, right? All your HTTPS website, they are using this technique called SSL handshake, right? So that is the main reason we are discussing this SSL handshake, right? So guys, in SSL handshake, we have around four type of protocols which involves in your SSL handshake entire process. The very first protocol is known as the SSL handshake. Second protocol is known as SSL cipher change protocol. Third protocol, which is SSL alert protocol. And the fourth one, which is SSL record protocol. So guys, these are the four protocol which involves in your SSL handshake. Just remember. Okay. According to OSI model, all these four protocol works between the application transport layer. And guys, see, if you know, we have a layer 4, and after that we just have a layer 7, right? But this layer 7 is a combination of your application layer, session layer, and presentation layer, right? So guys, all these protocols, they are a part of application layer, presentation layer, and the session layer. Just remember. SSL stands for Secure Socket Layer. SSL is a standard security technology for establishing an encrypted link between a server and the client machine. Means what will happen whenever any website is using SSL word, that time between that website and your PC, we are creating one secure tunnel, and that tunnel is known as SSL tunnel. And guys, whatever data we will exchange through this particular tunnel, all encrypted. Means what will happen? This particular SSL or TLS protocol, which is transport layer security, it will encapsulate all the packets of layer 7. See, your SSL only protect your layer 7 because at layer 7 we have the actual data, right? Now, in SSL handshake, client always initiate the connection. And guys, what is the first packet? First packet in that communication is always the TCP send request. Just remember. And this concept of SSL, it is developed by the company called Netscale. Netscale is the first company. They have introduced the SSL concept, and they have launched the SSL version 1.0, which they have not released. And after that, what they have basically created a new version, SSL 2.0. This is the one they have released, and SSL 3.0. And after that, this SSL 3.1 is also known as TLS 1.0. And nowadays, guys, we are using TLS 1.3 in most of the websites. Why we are using this particular TLS version 1.3, or like why websites are using this particular version? Because this is the most secure version. In TLS 1.0 and TLS 1.2, it has some type of vulnerabilities. Means hacker can able to exploit these vulnerabilities to gain the unauthorized access. Just remember. In SSL handshake, as I have mentioned, first TCP three-way handshake will happen, and after that your SSL handshake start. Why I'm mentioning here three TCP three-way handshake? Because this is the interview question. In interview, they will ask like, when my PC is communicating with the with one of the website hosted over HTTPS, like first SSL handshake happens or first TCP three-way handshake happen. Okay, now let's try to understand the SSL handshake in detail, right? So, as I have mentioned, I have written this SSL, I have basically created this SSL handshake explanation in couple of phases. Let's discuss phase 0. But in actual, it's not phase 0. Phase 1, I have mentioned this phase 1, but in actual, it's just a normal connection, right? So in the very first packet, what happens is known as client hello. And this particular client hello packet, what it will do, they will basically exchange the SSL or TLS version. Means this client is the device who will decide what is the version they have to use. They have to use SSL or they have to use TLS. And SSL and TLS both are similar, right? See, SSL is the old version, TLS is the latest version. That's it. Okay, and nowadays everyone is using TLS, which is transport layer security. So they have a in the very first packet, client hello what they have. Let me write down the parameters here. So they have a SSL or TLS version, right? They have a client random number. So guys, when this client start communicating with the server, what it used to, this client used to generate one random number, and it will basically send this random number towards the server, and that random number is known as a client random number. Apart from this random number, they will exchange the cipher spec. I can say cipher shoot. The meaning of cipher shoot is what? See, let's suppose this particular PC supported multiple encryption and hashing algorithm. Let's suppose this PC has a support of multiple encryption and hashing algorithms. So what it will do in cipher shoot, it will send all possible combination of encryption and hashing algorithms towards the server. Okay, cipher shoot. And apart from the cipher shoot, they will also exchange the compression algorithm. If there is any compression is needed, they will exchange the compression detail. And the cookies value or cookie value, or you can say it is also known as session ID. And initially session ID is 0, means client will send the session ID which is 0. Just remember. So in first packet, as I have mentioned, SSL TLS version, random number, session ID, cipher shoot, compression algorithm, and some extension fields. What are these extension fields? Let me write down the extension fields here. The most important part from the SNI field is extension field is SNI, means what they will say we have opened this particular server by using his IP address, then in SNI field they will basically send this IP address. Let's suppose if we are accessing the Facebook or server of facebook.com, then you will see in SNI field they will mention facebook.com. And guys, why this SNI is important? Because we have a firewall here, which is, let's suppose, a PaloAlto firewall. When PaloAlto firewall used to do the URL filtering, right? It will basically get the URL detail from this SNI field only. So that is the main reason I am basically explaining this SNI field here. Just remember. Now, this is the content of the very first message, which is known as client hello message, right? If you want to see the same thing with the hello Wireshark captures, you can see the Wireshark captures here. In Wireshark capture, you can see the very first message. This is your client IP address and this is the server IP address, right? They are using TCP protocol, and the very first packet is TCP SYN. Then TCP SYN is followed by the SYN plus ACK, and after that ACK, right? So till here, your TCP three-way handshake will complete, and after that you can see they have started the SSL handshake. In SSL handshake, the very first message is client hello, and you can basically check the packet of client hello. You can go into this transport layer security, Go to into this TLS version 1.2. They are using TLS version 1.2 and you can check the details. See, the packet name is client hello. Handshake type is client hello. This is the random number which I was mentioning. They will exchange the random number. This is the random bytes. This is the random number. And I have also told you they will exchange the session ID, and session ID value is also 0 in the very first message. Okay. And after that, they will exchange the cipher shoots. So here they have exchanged the 21 combination. And you can see here they have a combination of encryption and hashing algorithm along with the authentication method. Like in the first one, they are using ECDHE, which is a elliptical curve Diffie-Hellman algorithm with RSA. And for the for encryption, they are using AES 128 GCM. AES is a one of the encryption algorithm. And SHA-256 they are using as a hashing algorithm. Guys, what is the use of encryption? What we will achieve with the help of encryption? Encryption we will use to achieve the confidentiality. Confidentiality in your data means if there is any means we can, when this client and server wants to communicate with each other, right? Whatever data they will exchange, they should exchange in a secure way, right? No one able to see that data means this confidentiality feature we can maintain with the help of encryption algorithm like AES, 3 dash dash, right? RC4. These are the couple of encryption algorithm we are having. Now, guys, how we can achieve the integrity of your data? Means how we can make sure your whatever data we have sent towards the server, which is correct. It is not tampered by any attacker. We will we will maintain this integrity in your data with the help of hashing algorithm. In hashing algorithm, we have a MD5, SHA-1, SHA-256, right? These are the couple of hashing in this hashing algorithm we are having, right? And guys, how we can make sure we are communicating with the right person? How this PC know he has communicated with the right server? That particular validation we will do with the help of authentication, means with the help of certificates. Okay. So these are the 21 combination is sent by the client towards the server. And apart from this this cipher shoot, they have exchanged the compression method. Right now it is null, which means compression is not supported. And after that, they have a extension fields. In extension field, the very first field is server name, which is a SNI, server name indication. And here you can able to see the server name like 10.0.1.69. This is the server name, right? If you are opening that website using the facebook.com, then you can able to see the Facebook there, here, instead of that IP. Apart from that, it also have couple of other extension fields, but which is not required to know. Okay. So these are the details they will exchange in the very first message. Once they will complete the exchanging of the first message, what they will do? Now they will basically start exchanging the next message. In next message, what? They will exchange the server hello, server certificate, and server hello done. Means, as I have mentioned here, all these three particular packets, they will exchange in single go. They will not send server hello in a separate or server certificate in a separate packet. No, all these three messages generally come in the single packet only. Just remember. Now, in server hello, what? This server will send in server hello. This server will send the SSL TLS version. server random number, accepted cipher shoot, accepted cipher shoot, right? And the session ID. So guys, always remember the session ID. This time you will not get the session ID which is 0. You will get some value here for the session ID. So session ID is always provided by the server to your client. Just remember. Okay. Now let's try to see the packets of server hello. But before that, let me just tell you a couple of other things. See, SSL and TLS version is always decided by the client machine. In session ID, sometimes if session ID value is 0, which means we will get the new session ID from the server, right? Means 0 or null from the client side, and server will give the new session ID. In client hello, if we are just resuming one of the session ID, right, which means old session ID which provided by the server, new session ID we have resumed option, means we can also able to resume the session ID. Means sometime, let's suppose you have closed close the connection with the browser, right, or with the server, and after that you will reinitiate that connection. That time you can also allow to resume these sessions. Okay, but it is very harmful. If somebody hijacked your session ID, then he can able to basically launch the session hijack attack easily, and he can able to consume everything. When we resume the session certificate will not action. Just remember, if you are resuming the session, then there is no certificate action process. If session ID is null, then I don't have a resume session ID option. Okay, and most of the time you will see the null session ID provided by the server to the client. Now in server hello, selected SSL TLS version, selected cipher shoot, selected compression algorithm, server random number, and the session ID. These are the values they will exchange into the packet, which is server hello packet. SSL TLS version, which is the selected one, or the accepted one. Because let's suppose this client has sent TLS version 1.2, and let's suppose at the server end, server is only accepting the request from TLS version 1.3. That time your connection will not happen, it will fail. Just remember. Then they will exchange the server certificate chain. So guys, I will not discuss the certificate details today. So what used to happen, see, in this certificate chain, generally if you know the architecture of the certificate, we have a root certificate, then we have an intermediate root certificate, and after that we have a end user certificate. Right? Let's suppose this server is a Facebook server, for example, right? Then what will happen? Let's suppose Facebook server is a signed by the DigiCert. So you have a DigiCert's root CA, then you have a DigiCert's intermediate CA, and after that we have a Facebook certificate at the end. Let me just show you this thing from my browser so you can able to get the things properly. Let's take an example of YouTube. I'll go here. Connection is secure. Let me just open the certificate. Let me see the certificate detail. Now here you can see in this certificate, this particular certificate is issued to star.google.com, means all the websites like mail.google.com, videos.google.com, docs.google.com, everything. It's a wildcard certificate. Just remember. And the root of this wildcard certificate is root GTS root R1. Then the intermediate. So the first one is a root CA. Second one is known as intermediate CA. And this is the end user certificate. This is a end user certificate, guys. Okay. Now this is the most important certificate. Just remember. Okay. Now, if I'll go into this end user certificate, you will able to see the version, serial number, certificate signature algorithm, right? These are the algorithm they are using for creating the certificate. Issuer, these are the details of the issuer who has issued this certificate, right? Validity, it is having subject name, it is issues for google.com. Start.google.com means it will include almost everything or all the websites of Google, right? Then subject public key algorithm, then this is the most important part. This is the public key. Then it has some extension fields and you can able to check all these details. Certificate policy, and these are the alternative name of this certificate. Means this certificate they are also using for star.appengine.google.com, star.bdn.dev, star.origin-test bdn. Right? For all these particular websites of Google, they are using the same certificate. Just remember. And this is the certificate value. And this certificate will also have a public key, right? This is the public key, details and all. Now, why I am basically explaining these details? Because see, this is the content which is available into this server certificate chain. Okay, now if I'll go into my here and if I will open this message, let's try to see all the packet from the server hello first. As I have told you, in server hello, they are exchanging the SSL TLS version, then the server random number, right? Session ID. This is the random number details and the cipher shoot. So guys, you can see here in the client hello message, we have a 21 combination of cipher suit, right? But from the server, we are just able to see one combination. Means client or server, they have agreed on this particular method. Means they will use this method for encryption and hashing purpose. When they will basically encapsulate your data inside the TLS, they will use AES 128 CBC as an encryption algo and RSA as a hashing algorithm. And you can able to check some other details as well. Okay, so this is the details which they have in the server hello. Now you can open the server certificate. In this server certificate, you can able to see the certificate details. Okay, you can able to check the certificate detail here. You will get this exactly similar type of details like we have here. We will get all these three certificates. Okay, all these three certificates. Now, in this certificate, what they are having, they have this particular public key. They have this particular public key, right? So in this message, see, in this server certificate, this end user certificate, this one, right? Or the facebook.com, the end certificate has a public key, right? So what used to happen, this particular client, it will get the server public key. It will receive the server public key like this because it's a public key, so he can exchange with anyone. Now, what they will do now, they will use this particular public key to generate the pre-master key. So what it will do now, once this client receive this public key, right? So let me just go in this space. See, this particular client machine, generally when this client machine initiate the connection, it already has one public key and it also have one private key. Let's suppose public key value is 10 and private key value is 20. I'm taking these hypothetical numbers. One in actual, they are the very big numbers, right? And let's suppose this server also have the public key. Let's say public key is 5 or 6, and it also have a private key. Private key, let's suppose 7. Now, this particular public key, he will exchange with the along with this certificate, right? So this is the public key which we have received from the server side, which is 6. Okay, now let's move further. So we have seen the server hello, then we have a server certificate, right? Then server key exchange. So guys, there was one technology is available previously, which is a server key exchange, but nowadays this server key exchange is not happening until you enable the mutual authentication. I'm not going with the mutual authentication. I'm just going with the basic stuff as of now. Okay. So these optional thing I will not discuss in today's session. So I will bypass this. I will bypass this field and I will this server hello done. Now this is also optional field, means server may ask the certificate from the client as well, which is known as mutual authentication, means both party needs to authenticate with each other. Just remember. Okay. And after that, now this particular what happens now, client will initiate the client key exchange. Now in this client key exchange, what they will do, see, now guys, observe the main thing here. If you have seen here, we have we have a public key of client and we have a public key of server, right? We have a public key from the client, private key from the client. So now what happens, and also in this server hello, we have also this client machine got the random number of the server. So what it will do now, it will basically use the random number of client plus random number of server, plus it will this particular PC1, it will also use the public key here. And by using these values, what it will do, it will generate the pre-master key. Now let's suppose he has generated this pre-master key. Now this pre-master key, once it is generated, what it will do, it will encrypt this pre-master key using the server public key. What it will use the server public key to encrypt this pre-master key, and it will basically send this key value to us in the form of client key exchange message to us the server. And now if there is anybody who is basically watching that particular communication, see that person is not able to get this particular pre-master key value because it is encrypted by the server public key. And now there is only one way to decrypt this key, and for that you need a server private key. And guys, this server will not send this private key with anybody. Just remember, this particular private key is not sent by, or server will never share with anybody. And guys, what happens now in this client key exchange message, now this particular pre-master key is received here by the server. Let's suppose the generated pre-master key value is, let me just give here like 50. So we will get the value 50 here, right? Now what it will do, now see they have got the same value, right? And they are using the same method as well. They are using the same algorithm, right? What they will do now, with the help of this pre-master key, now they will generate the master key, and after that they will generate the session key. Now here also he will generate the master key, a master secret, then they will generate the session key. Let's suppose generated master key 60 here and session key 70 here. Here also they will generate the same. Here also they will generate the same. Now they are exchanging this change cipher spec message. In change, whatever message they will exchange here, this change cipher spec. When this client will send this change cipher spec message toward the server, he will use this particular key to encrypt this particular message, and he will forward this message toward the server, because server has also done the calculation and he has generated this session key. If this server is able to decrypt this message, if server is able to decrypt this message, if that key value is same, means if there is any problem with the communication, with the exchange process of a handshake, these keys will be different, right? And if they have a same key, then server will also able to decrypt that particular message, and after that server will also send the change cipher spec message, and server will just tell server hello done, and client will send client is also done. Means now they are telling each other we have generated the correct key, we are able to exchange the message properly, and we are able to decrypt the message which is sent by the each other, right? And after that, whatever data they will exchange here, the actual your application data they will exchange here, and now that data is encapsulated over the TLS, which is your transport layer security. So guys, that's how your SSL handshake happens in journal. There are multiple ways is also there. See, I have explained the SSL handshake using the RSA method. See, if they are using ECDHE method, then there is a slight changes with regards to the encryption and with regards to the key exchange process. Okay. So these things you can maybe do it by yourself. And if you want to see the same details here, let me just go into here. See, in the server certificate, as I mentioned, they have a public key, right? This is the public key they are having. Now they will use the same public key, and you can see this client key exchange change cipher spec and encrypted handshake message, right? Or the client done message, right? In client key exchange message, if you will open this message, you can see they are exchanging RSA encrypted pre-master secret. So they will exchange this particular pre-master secret, and how they will basically generated the secret, what they will do, they will apply the encryption. They will basically encrypt the pre-master key which they have generated here, okay, with the help of server public key. And how how PC1 or how client get the server public key, he will get from the server certificate, which is also known as digital certificate or identity certificate or the end user certificate. Okay, do not confuse with these terms. And after that they exchange the chain cipher spec. It's nothing in chain cipher spec, they just encrypt that message. And last message is handshake protocol, which is encrypted handshake. Okay, then in the servers and chain cipher spec and encrypted handshake. That's how your SSL handshake is completed with regards to your SSL handshake is completed. And after that, whatever application data they will exchange, everything is encapsulated. See inside the transport layer security, which is TLS protocol, and this is your actual application data. Okay, so that's how the SSL handshake happens in your normal communication between a server and the client, right? Now there's a multiple things we also need to know when I will discuss the same part in your live sessions. That time I will go through with multiple things. Let me just open it properly. Here also, if you will see, like master secret used to generate the symmetric session keys, right? So in this diagram, if you will see, this client key exchange method is also known as a pre-master secret exchange process. Okay. And after that, they will basically go with the client finish, server finish, this particular things. So that's how the SSL handshake works. Now there's a multiple flavors of this thing. Like this is the architecture of your certificates. If somebody is not having the idea, we have a root certificate, then we have a couple of intermediate certificate, and after that we have a end user certificate. Okay. And see, there is a proper architecture is also there. You need to know with regards to the certificate and all, right? Then there is a multiple things happens with regards to your SSL inbound inspection and SSL outbound inspection, right? So all these things I will cover in your practical classes when I will basically start that particular batch. So this is this is what which I wanted to cover with regards to the SSL handshake for now, guys. Now, with regards to SSL decryption and all, there is a multiple thing we have to know how Palo Alto Firewall is going to do the processing and all, right? Everything, and how your TLS, your transport layer security, what it will encrypt all the data of application layer and the presentation layer. Just remember. And apart from that, see, only this data is encrypted. Apart from everything in clear text means they can able to see the port numbers, TCP or UDP port numbers, your layer 3 information, your layer 2 information is if somebody is capturing that particular information. Okay, so this is what which I wanted to discuss with regards to SSL. Now, guys, let me just go through with the course content of Palo Alto. So, as I have mentioned, this particular in this training, I will cover the Palo Alto at the PCNSC level. And the total duration of these classes is around 45 plus hours. We have around total of 16 classes, and your classes will happen Saturday and Sunday starting from 9 a.m. to 12:30 p.m. IST. Now, in the very first class, I will start with the platform and architecture, where we will discuss what are the hardware model is offered by the Palo Alto, what are the virtual devices or virtual VMs offered by the Palo Alto, right? What is the SFCN or the cloud native firewalls from the Palo Alto? So all these platforms we are going to discuss how the architecture and everything, right? Once we will complete, I'll just move towards the architecture where I will discuss the SP3 architecture of Palo Alto. Means what is single pass software and parallel processing hardware, because in any type of interviews they will ask what is sp3 in Palo Alto. So if you know the sp3, then only you can able to answer this thing properly. Okay, so I will cover your sp3 architecture of Palo Alto. Once I will complete with that, I will basically start the flow logic or the life of a packet or the life of a session inside your Palo Alto firewall, or how packet Palo Alto Firewall is doing the packet processing. I will go through with the all these stages like ingress stage, flow lookup, then session setup stage, then we have a fast path, then we have a app ID, content ID, and the forwarding stage. We will see everything in depth here. So I'll generally used to take around 3 hours of time to complete the entire flow logic as per the latest operating system of Palo Alto, right? Once this part will complete, I will move towards the initial configuration, means how we can basically access the Palo Alto firewall very first time. What, how we can able to configure the management interface with the IP address, default gateway, DNS, NTP, domain name, host name, with the help of CLI using the console cable, or with the help of CLI using the SHS, right? Or how we can enable this SHS, HTTPS, all these type of things I am going to cover. Once this part will complete, I'll move towards the licensing and software updates, means how I can we can able to activate the license if we have a auth code, how we can able to do the Palo Alto Firewall registration into the support portal, right? Then how we can download, how we can activate these auth code from there, then how we can fetch the license directly from the support portal, or we can directly download these license keys into your system, and later on we can upload these particular keys into the Palo Alto firewall to activate the license, right? So all these things I'm going to cover here. When this part will complete, I move towards the software updates and the dynamic updates. Let's suppose you want to perform the updates with regards to the Palo Alto firewall operating system. Let's suppose from version 10.0.0 to 10.2.5, then what is the path? How we can do all these things I will cover, right? And with regards to your dynamic updates, let's suppose we want to download the application updates or threats updates or the wildfire updates, right? How we can schedule these particular updates so automatically Palo Alto 5 will download and install them, right? Everything. Then your account administration means how we can able to create the account for different team, and how we can create account for L1 engineers, L2 engineers, L3 engineers, how we can restrict the access of these particular engineers on your Palo Alto firewall. So these things I am going to discuss with regards to the account administration. I will also show you how we can basically integrate your Palo Alto firewall with the radius. Like, because if you want to control your Palo Alto authentication with the help of Cisco ICE or the Aruba Clear Pass, right? Or the any type of other NAC device, right? Or maybe Windows AD. Then you have to make an integration of the Cisco ICE or Aruba ClearPass using the radius protocol. Then I will show you how we can create the radius profile, then how we can create a connection with them, right? Everything. Then admin roles, how we can create the roles for your network engineers, for your SOC engineers, all these things I will cover in your admin roles. Then how we can able to basically make the interface related configuration, right? How we can configure the IP address on the interface, how we can enable the ping, HTTP, telnet, such as all these particular protocols on your data port. Everything I will cover here, and all these things we can able to create with the help of interface management profile. So we will discuss that part. Then I will discuss your security zones, how we can basically assign an interface inside a security zone. All these things we will discuss, right? What is intra-zone communication, what is inter-zone communication, all these things we will understand. Then I will discuss how we can deploy Palo Alto firewall in layer 2, how we can deploy Palo Alto 5 in layer 3. Then what is virtual wire deployment or bump in the wire deployment or the transparent deployment. Then we will discuss how we can deploy Palo Alto firewall in tap mode or the promiscuous mode, right? So all these deployments mode we will discuss along with the practicals. Then I'll discuss the concept of sub interfaces. Then how we can able to configure the how we can use Palo Alto firewall as a DSCP server or DSCP client or as a DSCP relay agent, right? All these things I will cover. Then I'll discuss the virtual routers. So guys, in Palo Alto firewall, if you want to configure the routing protocols, we have to go with the virtual router concept. I will discuss how we can create a virtual router, means multiple virtual routers. Maybe one virtual router is for the static routing and another virtual router for the BGP routing, or maybe another virtual router for the OSPF routing. Then how we can allow the communication between these multiple virtual routers, right? It is a similar type of setting, like we have a different small routers inside the Palo Alto firewall to manage the routing related things, right? So I will cover that part as well. And guys, during this time, I will also discuss your policy based forwarding, your path based routing, right? Dual ISP setup, all these particular practicals I will also cover at the same time. When this part will complete, I'll move towards the security policies and net policies, right? Security policy configuration, policy administration. Then in net, we will discuss like what is source net, what is destination net, what is U-turn net, right? What is static net. Then we will see how we can basically configure the destination net with one-to-one mapping with port forwarding, right? So all these type of use cases we will discuss with regards to net as well. Then your app ID, what is application identification, what is app id overview, right? How Palo Alto firewall is going to process the TCP packets, UDP packet with regards to app id, right? Or how app engine is going to handle this TCP connections and UDP connection, how it is basically doing the app identification, what is app id cache, right? Which is which is created by the Palo Alto firewall, what is application groups and filters, right? because see inside Palo Alto Firewall it has a support of around 4500 applications. Then let's say you can create a group of, let's say, 10 applications or 20 applications, and you can basically take the action. You can allow them or block them. You can also create the filters, like because Palo Alto Firewall will provide you the filters, right, on the basis of media related application, or like on the basis of technology like peer-to-peer application, or the on the basis of risk level, right? Let's say you want to block all the risk level 5 application, so we can able to create a filters and we can able to allow a block that type of traffic. Then we will discuss the content id overview. In content id we will see what is antivirus profile, what is anti-spyware profile, vulnerability profile, right? Then your URL filtering, external dynamic list, file blocking, security profiles, wildfire. And guys, when I will discuss all these particular practicals on content ID, what I will do, I will launch all these type of live attacks actually. I will try to exploit the vulnerabilities of my Windows servers, right? I will basically create one malicious or the one virus, and I will try to download that virus, and we will see how firewall is protecting. And all these things I will basically able to perform because on my lab I have this Kali Linux, and I can able to do everything with that particular Linux machine. Okay. Then I will discuss what is zone protection and DOS protection. In zone protection and DOS protection, I will also cover how we can able to launch the network attack. Network attack means how I can able to launch majorly the DOS attacks or DDoS attack like TCP SYN flood, UDP flood, then ICMP flood, or other IP related floods. Then how I can launch the IP spoofing attack, host sweep attack, right? All such type of attacks I will launch, and I will show you how I can basically choke my Palo Alto firewall with these many packets, right? How I can able to consume the entire session, because every device has a session capacity, right? So if I will consume all the sessions, then it will not able to process the legitimate request from the users. Then I will show you if I will enable zone protection and DOS protection, how we are getting the protection from such type of attacks, right? Then in your decryption, I will go through with the SSL decryption, SSL handshake in depth, right? See, today I have just completed your SSL handshake in 20 SHS SSL handshake in 20 minutes, but in live session I used to take around 1 hour because there are lots of other parameters which I used to discuss, right? Then certificate management, what is the meaning of root certificate, intermediate certificate, digital certificate, how the exact architecture is happens, how we can generate the CSR, then how root authority or like root CA, they will give you the certificate, everything we will basically see here. Then on this part will complete, then I will also explain you how outbound SSL works and how it is implemented inside the Palo Alto, how inbound SSL decryption happens and how it is implemented inside the Palo Alto firewall, right? What is the Palo Alto proxy engine, how it is basically stripping your SSL related packets and how it is doing the processing, right? So all these tasks I will cover. Then your SSH decryption, because nowadays most of the attack is happening using the SSH tunnel, right? We can, so because inside SSH tunnel we can send any protocol data, right? And if somebody is doing this, then how we can basically protect. So all these tasks we will do with regards to the practical. Okay. Then your user ID related practicals, because nowadays IP address of users machine is not fixed, right? They are getting the IP address from DSCP in an organization, but user ID is fixed for the users, right? So what we can do, we can able to configure the user based policies. We can do the active directory integration, IP to user mapping, how we can basically integrate the user IDs and with Palo Alto, right? So all these tasks we will do with regards to the user ID class. Here I will also discuss the captive portal, how captive portal authentication works, right? Then how, let's suppose we have a HR user from HR group, user from sales group, user from marketing group, then how we can write the group based policies. So all these particular tasks we will see. When this part will complete, I will cover your IPsec site to site VPN. Like I will go through with the advanced explanation, like how phase one exchange works, how phase two exchange works, what is IPsec tunnels, right? Then I will also go through with around 13 use cases of your IPsec VPN. All these particular use cases we will see practically. So it will cover everything with regards to your IPsec VPN. Then I will basically start your Global Protect, which is a remote access VPN solution from Palo Alto. I will go through with the Global Protect connection flow, because if you want to do the troubleshooting, you have to know that connection flow. Then Global Protect connection method, like what is user logon, what is on demand, what is pre-logon, then on demand, what is pre-logon, then user logon, right? All these particular four methods we are going to discuss with practicals. And guys, in your IPsec or in your global protect, see, I will also try to show you how we can able to decrypt your SSL related packets, how we can able to decrypt your IPsec related packets, right? To see the internal things. Whatever keys today we have seen, right? I will decrypt these keys and I will show you this. These are the keys, looks like that actually. So everything we will basically discuss here along with the daemon level information on Palo Alto. So one, then your syslog integration, net flow, log type. One this part, guys, panorama I will not cover on this training. Okay, just remember. Then your high availability active passive HA, active HA, right? All the practicals with regards to active HA and active passive HA we are going to discuss. Then I will run the webinar as well on troubleshooting like packet filter, packet capture, flow basic, TCP dump, how we can do the management plane troubleshooting or data plane troubleshooting, right? So all these are the tasks which I am going to cover in this particular training. Okay, if you want to join this training, you just need a basic knowledge of like a routing switching, like you should be good with the routing switching related things. And as I mentioned, guys, panorama I will not cover in this training, because panorama I used to take a separate batch altogether for panorama, and panorama is around 30, more than 32 plus hours of training, just remember. Okay, now if somebody is interested to join this particular batch, which we are starting from 24th of Feb, so morning weekends batch, these are the contact numbers. You can write down these contact numbers, take the screenshot of these numbers, and you can contact us for the enrollments. This number belongs to me, and the second number belongs to Bidit sir, and we will help you with the enrollment process and everything. Okay. Okay, guys, so this is what which I wanted to cover with regards to your today's webinar. Now let me just give you the chance for question and answers.